Let's see what happens when the exponent in the exponential number is 0 or negative. Before we do that, let's look at the familiar exponents, which are positive whole numbers. So let's look at this: 2 to the power of 4, 2 to the power of 3, and 2 to the power of 2, or 2 squared. What are the values? The values are 16, 8, and 4. Do you see some pattern here? You can see that the exponent gets reduced by 1 every time, whereas the value of the number is getting half or divided by 2. So 2 to the power of 4 is 16, and you divide 16 by 2, you get 8. Divide again by 2, you get 4, whereas the exponents are getting reduced by 1 from 4 to 3, from 3 to 2. So if we reduce further, you will get the exponent as 2 to the power of 1, and divide 4 by 2, so you get 2. So 2 to the power of 1 equals 2. What happens if you reduce the exponent further? Subtract 1 from this, so you will get 2 to the power of 0, and you are going to divide the previous value by 2, so you are going to get 1. That means it looks like this: 2 to the power of 0 equals 1. Why are we dividing by 2 here? Because the base is 2. The very definition of exponential number says that we multiply the base. That means when you have 2 squared, you multiply 2 times. When you have 2 cubed, you multiply 2 3 times. That means when you increase the exponent by 1, you multiply the value by the base one more time. So if you reduce the exponent, you are going to divide it by the base. Let's look at one more example. I have written here 10 squared, which is 100, and you reduce the exponent, which is 10 to the power of 1 equals 10. What happens here is that you are now dividing the value by 10. Why? Because the base is 10 here. When the base was 2, you were dividing by 2. When the base is 10, you are dividing by 10. And after 10 to the power of 1, reduce the exponent further by 1, so you get 10 to the power of 0. Divide 10 by 10, so you get 1. So 2 to the power of 0 is 1, 10 to the power of 0 is 1. Even if you do this for 20, 40, 100, for any number, the power 0 equals 1. Let's verify this by one more method. Consider this: 5 squared divided by 5 squared. We know that any number divided by itself equals 1. So this equals 1. But we know the exponent rule that says when you divide two numbers and the base is the same, you just subtract the exponents. So in this case, the base is the same, which is 5. So let's subtract the exponents, which is 2 minus 2 equals 0. That means the answer of this division is 5 to the power of 0. And we already know that answer of this is 1. That means 5 to the power of 0 is 1. So now you can see that any base to the power of 0 always equals 1. So 3 to the power of 0 is also going to be 1. 20 to the power of 0 is also 1. So if I want to express this using a variable, it looks like this: a to the power of 0 equals 1. A is a variable here, so you can put any value there, whether it is 2, 10, 5, 3, 20. For any base to the power of 0 equals 1. Now what happens if the base is negative? It's quite similar to what you have learned so far. If you continue the same pattern further, so if I consider 2 to the power of 0 equals 1, and if I reduce the exponent by 1 and divide the value by 2, I'm going to get 2 to the power of negative 1 equals 1/2, or 1 over 2. If I continue this and go further down, it is going to look like this: 2 to the power of negative 2 equals 1 over 4. 1/2 divided by 2 equals 1 over 4. And if I go further down, it's going to look like this: 2 to the power of negative 3 equals 1 over 8 because half of 1 over 4 equals 1 over 8. Let's do the same thing for the base 10. Consider 10 to the power of 0 equals 1. Reduce the exponents, so we get 10 to the power of negative 1, and divide the value by 10, so you get 1 over 10. Dividing by 10 is the same as multiplying by 1 over 10. So if I go further down, if I continue this, I'll get 10 to the power of negative 2 equals 1 over 100. 1 over 10 multiplied by 1 over 10 equals 1 over 100. So this is how negative exponents work. Now consider 2 to the power of negative 1 again. It equals 1 half or 1 over 2. 1 over 2 can also be written as 1 over 2 to the power of 1. Similarly, 1 over 4 can be written as 1 over 2 to the power of 2 because 4 equals 2 squared. And 1 over 8 can also be written as 1 over 2 to the power of 3. So you can see that 2 to the power of negative 2 equals 1 over 2 to the power of positive 2, or 2 to the power of negative 3 equals 1 over 2 to the power of 3. The same thing happens for the base 10. 10 to the power of negative 1 equals 1 over 10 to the power of 1, and 10 to the power of negative 2 equals 1 over 10 squared. So what do you see here? What's the pattern? You can say that a to the power of negative m always equals 1 over a to the power of m. Or you can also say that a to the power of m equals 1 over a to the power of negative m. That means whenever there is a negative exponent, you can make it upside down and change its sign. If you turn it upside down, then the sign of its exponent is reversed. So this is something new, interesting you have learned. I have summed up the rules that you learned just now, which is a to the power of 0 equals 1 and a to the power of negative m equals 1 over a to the power of m. Now all this works fine, but there is something you need to know more when a equals 0. So in case of a to the power of m, what happens if a is 0? That means the base is 0. When the base is 0 and m is positive, how is it going to look? It's going to look something like this. For example, 0 to the power of 3. 3 is just some positive number I have taken. You could take anything, 0 to the power of 10, 0 to the power of 27, anything. So this means 0 multiplied by 0 multiplied by 0. So it equals 0. So 0 to the power of anything, any positive thing is always going to be 0. This is quite easy. What happens if m is negative? That means your base is 0 and the exponent is negative. So consider 0 to the power of negative 3. It will look like this. Based on the rules, it will look like 1 over 0 to the power of 3. And we know that 0 to the power of 3 is 0. That means this looks like 1 over 0. Now 0 is in the denominator. Are we allowed to divide by 0? No. Divide by 0 is not defined. Therefore, this thing is not defined. That means if the base is 0, negative exponent is not defined. That is not allowed. Now here is an interesting case. What happens when m is 0? That means the base is also 0 and the power is also 0. Some people think it should be 0 because 0 multiplied with itself 0 times is 0. 0 to the power of anything which is not negative is 0. So some people think it should be 0. But we know that anything to the power of 0 is 1. So some people think 0 to the power of 0 should also be 1 because anything to the power of 0 is 1. Therefore, at this stage, when you are in high school, for high school mathematics, we can say that this is indeterminate. This is not determined. When you learn more advanced maths, when you do further studies, then you can discuss more about it, and then we can learn more about whether it is 0 or 1. But at this point of time, this is what we know for 0 to the power of 0.